Take a moment to read Unit 2, Lesson 15, Practice Problem number 7. In this practice problem, students are required to know the properties of parallelograms to prove that two triangles are congruent. Previously, students have used triangle congruence statements to prove two triangles are the same size and shape. At this point in the unit, students are encouraged to focus on using properties and theorems rather than transformations. Let's start with reviewing the various parallelograms. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. When we see those parallel lines, they will have a marking of arrows to represent that our lines are parallel. Okay, notice that the top and bottom have one arrow, whereas the right and left have two arrows. It is just showing us that the top and bottom are parallel to each other, and the right and left side are parallel. Notice that some people may see and notice that this one, the second picture, kind of looks like a square. Well, a square is a parallelogram because, again, our property for parallelogram is that opposite sides are parallel, and that does happen in a square as well as a rectangle in the next picture. So we can call all of these parallelograms. As we begin to get more specific with four-sided shapes, you will see rectangles. So what makes something a rectangle? A rectangle is a quadrilateral that has four right angles. So not only does it have opposite sides parallel, but now we have that additional piece of now the angles have to be 90-degree angles. Notice that again in this picture, it looks like we have a rectangle that looks like a normal rectangle we're used to seeing, but there's also a square. A square is a rectangle because again, the only property it needs to fall into is that it has four right angles. Next, we have our rhombus. So a rhombus is a quadrilateral that has four congruent sides. So notice that each one of our sides in this picture has tick marks, and they're all the same amount of tick marks, representing that all four of these sides are the same length. Okay, again, notice that this picture looks like it has a square. So far, we've seen a square in all of these because a square is very specific in what it requires. A square requires that we have four right angles and four congruent sides. So as students start to say and talk about their quadrilaterals, we do expect them to be specific with what type of parallelogram they have, whether it's just a parallelogram that has opposite sides parallel, does it have four 90-degree angles, does it have four congruent sides, or does it only have one or two of those characteristics? Now that we know what a parallelogram is, remember parallelogram is opposite sides are parallel. Let's use that to answer our question. So again, they are telling us that this is a parallelogram. That means the first thing that we know is we have parallel lines. So I'm going to go ahead and mark. I know that KL is parallel to NM. Those are opposite sides. I know that those are parallel. Notice I'm not putting tick marks because that is not the property that we're using. I also know that KN is parallel to ML. Again, I had to put that second set of arrows there because those are not parallel to my first sides, but they are parallel to each other. So notice, if I were to write this out, I would say that this is a parallelogram. So I know that line MN is parallel to line KL, and that line KN is parallel to line LM. From there, we would start thinking about the angles. Some of the vocabulary that we've talked about with angles are same side interior angles, alternate interior angles, corresponding angles. We've given all of those. So our goal is really to look at these parallel lines cut by a transversal, and we're going to see if we can name some. In this case, we're going to do alternate interior angles. So I can see if I'm looking at my parallel lines, MN and KL, I see that my transversal is LN. If I'm looking at alternate interior angles, I see that MNL, this angle right here, is going to be alternate interior to angle KLN. These two are going to be congruent because they're alternate interior angles. Now, when I do the next piece, I need to now change which parallel lines I'm looking at. Now I'm looking at my parallel lines ML and NK, and I am looking for, again, my transversal still happens to be NL, but this time I'm looking for my angles here that would be alternate interior. So notice that KNL is going to be congruent to MLN because they are alternate interior angles. Okay, so that's how we would write it. I'm going to clean up my picture just a little bit so that you don't see all of these extra lines. So give me just 1 second. Oops. Okay, so I'm going to put my parallel lines, markings, and then I'm going to go ahead and put my angle markings again. Okay, now that we've done that, now we have been talking about in our class what we call the auxiliary line. What the auxiliary line is it takes our shape and it cuts that shape into smaller shapes. So in this case, our auxiliary line happens to be line LN. So I'm going to go ahead and put a tick mark on that because I know that I drew the same line for both of those. That's what it really means to be the auxiliary line. And when we write this as a statement for the auxiliary line, we would say something like that line NL is congruent to line segment LN because they are the same segment. Okay, once I have proved that, now I know that my two triangles are congruent because I now have my theorem, angle, side, angle. Okay, so how we would write that is we know that our two triangles are congruent because we use the angle, side, angle theorem.